This is ComputerSystem T229. So in this video we're going to be looking at CPU allocation of resources to see how algorithms work and which one answers our question. So the question here, which of the following is a task scheduling algorithm where a specific task has a high possibility of waiting indefinitely for the allocation of CPU resources? So here we have four answers, two of which are on this slide and two of which are on the next. So A, each task is executed according to the order in the CPU queue. And once the fixed period of time has elapsed, the execution of a task is suspended and is appended to the end of the CPU queue. B, the priority of each task is determined and tasks are executed from highest priority to lowest priority. However, the priority is increased gradually according to the length of time waiting in the CPU allocation queue. So the last two options on this question are C, tasks are appended to the end of the ready queue in order of arrival to the system, and the CPU is always allocated to the first task in the ready queue. And D, processing is performed from the task with the shortest expected processing time. When the processing that is currently being executed is completed or suspended for some reason, the next task is started. So here, the scheduling algorithm by which processing is executed in order starting from the last task job with the shortest expected processing time is called SJF, or shortest job first algorithm. This algorithm is suitable for preferentially processing tasks that need to be handled immediately, such as online real-time processing. However, when tasks with short expected processing time arrive at the CPU resource queue in quick succession, the tasks with long expected processing time wait indefinitely for CPU allocation of resources and might not be processed for a long time. Therefore, D is the correct answer here, and we have been describing in the question the SJF algorithm. So let's have a look at some of the other options that we had in the answers to our question. So the limited time period for which the CPU can be used is called a time quantum, or a time slice. Once the limited time period is reached, the execution task is suspended and the task is appended to the end of the CPU resource queue. This is managed by a scheduling algorithm called the round-robin algorithm. The tasks in the CPU resource queue are processed in sequence, and the allocation of CPU resource tasks is ensured. The scheduling algorithm, where multiple CPU resource queues are created according to task priority, and CPU resources are allocated sequentially, starting with tasks with the highest priority, is called priority scheduling. The problem with this algorithm is that CPU resources are not allocated to tasks with a lower priority very often. The process of gradually increasing the priority according to the length of the waiting period so as to deal with this problem is called aging. So in C, this is an algorithm by which tasks are processed in order of arrival. This is called FIFO, or first in, first out. Although the subsequent tasks are made to wait, once a certain amount of time has elapsed, the CPU resources are eventually allocated to subsequent tasks as well. And so here we can see that our answer is D. In this video, what we've looked at is CPU resource sharing algorithms and how we can allocate tasks in the most effective way. And we've just looked at some of the ways and methods of doing this.